10 times more electricity. That's how much a single conversation with an advanced artificial intelligence can consume, compared to a simple internet search. Multiply that by billions of uses a day, across the whole world, and you reach a number that scares engineers. Artificial intelligence is hungry, and electricity hunger growing faster than almost anything in the economy. We talk about the cloud, the digital, the virtual, as if they were light, ethereal, weightless things. But there is no cloud. What exists are gigantic warehouses, the size of neighborhoods, full of chips that heat up, drinking electricity day and night, and consuming water to cool down. The digital future has a physical body, a very physical one, and almost nobody looks at it. In this episode, I won't give you investment tips or tell you what to bet on. That's your call. I'll show you the uncomfortable truth behind the entire AI revolution. It runs into a limit that isn't software. It's physics. Intelligence can become cheap and abundant, as we've discussed on this channel. But the energy that feeds it isn't free, and may not be abundant enough. And that single constraint could decide who rules the future. It all starts by understanding why thinking costs energy. Let's start with a physical truth we forget. Processing information costs energy. It always did. Your own brain, that extraordinary machine, consumes about a fifth of your body's total energy, even though it weighs little. Thinking costs. And with computers, it's no different. Every calculation, every bit manipulated, requires electricity and releases heat. For decades, this wasn't a visible problem, because chips kept getting absurdly more efficient, doing more calculations with less energy, year after year. Computing seemed almost free. But artificial intelligence changed the scale of the game brutally. Training and running these giant models isn't like doing a simple calculation. It's doing trillions of calculations, repeatedly, for each answer. The amount of processing behind a single answer from an advanced AI is of an order that ordinary computing never demanded. And here's the turn few noticed. The efficiency gains of chips, which always saved us, are now chasing a demand that grows even faster. It's like a treadmill that accelerates more than you can run. Each new chip is more efficient, yes, but we want so much more artificial intelligence that the total consumption soars anyway. And that leads us to the place where all this hunger materializes. Look, the data centers. There are, scattered across the world, gigantic buildings almost nobody sees, but on which your entire digital life depends. The data centers. They're warehouses the size of several football fields, windowless, full of rows and rows of blinking servers, running 24 hours a day, 7 days a week, never stopping. Every time you send a message, watch a video, or talk to an artificial intelligence, it's one of these places working for you, somewhere on the planet. They're the invisible cathedrals of our era, and they have two hungers. The first is electricity. A single large data center can consume as much energy as an entire mid-sized city. The second, less known, is water. All that processing generates immense heat, and much of these places use water to cool down, sometimes millions of liters. Now add the artificial intelligence race to this. Companies are building ever bigger data centers at a frantic speed to keep up with the demand for AI. In some regions, the electricity consumption of these centers already begins to rival that of entire sectors of the economy. The question energy engineers are asking, in a low, worried voice, is simple. Where will all this electricity come from? Wait, because the answer to that question runs into a wall of physics. Here's the fundamental difference between the world of software and the world of energy, and it's a difference that changes everything. Software lives in a world of abundance. You copy a program 1 billion times and it costs nothing extra. Information is almost magical in that sense. But energy lives in the world of physics, and physics has hard laws nobody bends. To generate electricity, you need plants, fuel, panels, turbines, things that take years to build and occupy real space. To transmit that energy, you need lines and grids that don't rise overnight. While demand for artificial intelligence can double in months because it's software, The supply of energy takes years, sometimes decades, to catch up, because it's concrete, steel, and environmental permits. That mismatch is the wall. On one side, a digital demand growing at the speed of thought. On the other, a physical infrastructure growing at the speed of cement. And when a demand that doubles fast meets a supply that grows slowly, the result is predictable. Either energy runs short, or it gets expensive, or both. Artificial intelligence, the most advanced technology we've ever created, could end up limited not by a lack of ideas, but by a lack of the oldest and most brutal thing there is, enough electricity. And this, however, reopens a dispute that seemed like a thing of the past. For much of recent history, we stopped thinking of energy as a daily strategic question. It seemed to simply be there, in the socket. Artificial intelligence is changing that, bringing back an old truth. Whoever controls energy controls what can be done. Think about the logic. If running cutting-edge artificial intelligence requires enormous amounts of cheap, reliable electricity, then the places that have that energy become the places where AI can flourish. Suddenly, having an abundance of energy isn't just an industrial advantage. It's an advantage in the most important technological race of the century. Countries and regions with plentiful, cheap energy attract the data centers, attract the development of artificial intelligence, attract the economic power that comes with it. Those who depend on expensive or scarce energy fall behind, not for lack of talent, but for lack of watts. It's a geopolitical reversal happening quietly. Energy, which always moved wars and empires, returns to the center of the board, now tied to the intelligence of machines. And there's a deep irony here, connecting with what this channel has discussed. Artificial intelligence promises the age of abundance, but to reach it, it first has to overcome a very concrete scarcity, that of energy. The machine that could free us depends on a limited physical resource. And later, this is where the problem stops being technical and becomes a choice about the planet. Now the thorniest part, and I'll treat it honestly, rooting for no side. All that electricity artificial intelligence devours has to come from somewhere. And that creates a dilemma. If the energy comes from fossil fuels, the AI race could work against efforts to contain climate change at exactly the moment the world tries to cut emissions. There's already a real debate about data centers reigniting demand for polluting sources to keep up with the rush. On the other hand, there's an opposite argument, also legitimate. Artificial intelligence itself can help solve energy problems, optimizing power grids, accelerating research into new ways to generate and store electricity, making everything more efficient. And AI's energy hunger can, paradoxically, fund and speed up the building of a lot of clean energy, because companies have money and urgency to lock in electricity. There's even a movement of tech giants betting on sources that once seemed distant, like next-generation nuclear, precisely to feed their data centers. So AI is, at the same time, an energy problem and a possible part of the solution. Which side wins isn't decided, and it's an open projection. What's certain is that artificial intelligence turned energy from a technical detail into the central bottleneck of the future, and every central bottleneck in the end becomes a race. What's happening now, far from the headlines, is a quiet billion-dollar race for the fuel of intelligence, energy, and the chips that turn it into thought. The biggest tech companies in the world stopped competing only for talent and data. They're competing, more and more, for access to electricity and processing capacity. Contracts are being signed to lock in energy for decades. Companies are buying or funding entire power plants just to feed their data centers. It's a revealing shift in mindset. Software companies, which always lived in the light world of bits, are now burying themselves in the heavy world of energy infrastructure because they realized that's where the limit is. Whoever secures abundant, cheap energy first gets a head start in the artificial intelligence race. And chips are the other half of this race. The specialized processors that run AI are extremely expensive, hard to manufacture, and concentrated in the hands of very few companies and countries. Controlling the manufacture of these chips became a national security matter, with countries competing not to become dependent. Energy and chips, these two physical resources, and not the algorithms, may be what actually decides who leads the future, and that completely changes who has power in this story. But first, you need to understand a hope that comes from physics itself. Before this all seems like a dead end, it's fair to present the biggest source of hope, and it comes from the history of technology itself: efficiency. The entire digital age was built on an absurd and continuous improvement in the efficiency of computing. Today's chips do, with the same energy, millions of times more calculations than those of decades ago. And this pursuit of efficiency hasn't stopped. On the contrary, the pressure of AI's energy hunger is accelerating it. There are several promising fronts. Researchers work on smaller, more specialized artificial intelligence models that do the job with a fraction of the energy of the giant ones. There are advances in chips designed specifically for AI far more efficient. And there are even radical approaches, inspired by the human brain itself, which is incomparably more energy efficient than any computer. Remember what nature already discovered. Your brain does things the largest artificial intelligence still can't, spending the energy of a dim bulb. That proves it's physically possible to be vastly more efficient than we are today. The optimistic bet, which is a projection and not a guarantee, is that efficiency advances fast enough for artificial intelligence to fit within the planet's energy budget. But history also teaches a cruel trap about efficiency that almost nobody takes into account. There's a paradox in the history of energy that must be known, because it haunts any easy hope based on efficiency. It's called the Jevons paradox, and the idea is counterintuitive but powerful. When a technology becomes more efficient at using a resource, the total consumption of that resource often increases instead of decreasing. It sounds absurd, but the logic is simple. When something becomes cheaper and easier to use, we use much more, and later even more. In the 19th century, steam engines more efficient at using coal didn't reduce coal consumption. They increased it because cheap steam was used everywhere. The same can happen, and probably will happen, with artificial intelligence. If running AI becomes 10 times more energy efficient, the temptation won't be to use the same amount of AI spending 10 times less. It'll be to use 100 times more AI in everything, because now it's cheap. Efficiency, instead of easing the energy hunger, can end up feeding an even bigger appetite. This doesn't mean efficiency is useless. It's essential. It means that alone, it probably doesn't solve the problem, because demand expands to fill the capacity. That's why the experts discovered we won't get out of this just by saving. We'll also need a lot more energy, and preferably clean. And that need ties this story to all the others on this channel. Now let the Nexulus lens join this with everything we've seen. In the episode on the economy of abundance, I said that almost everything that has a cost in the world comes down to two inputs: energy and intelligence. Artificial intelligence is making intelligence abundant and cheap. But this episode reveals the other half of the equation. Cheap intelligence only becomes true abundance if energy is also abundant and cheap. The two inputs are tied together. Think of everything we saw in this cycle: the artificial intelligence agents that take over work, the robots entering homes, the science trying to reverse aging. All of them, without exception, run on computing and therefore on energy. The home robot needs electricity. AI-accelerated longevity research needs data centers. The agents that coordinate need processing. Energy is the invisible soil on which the entire future we're describing rests. And that's why the energy hunger of artificial intelligence isn't a boring technical detail. It is, perhaps, the most fundamental constraint of all. If we don't solve energy, everything else stalls. The abundance of intelligence runs into the scarcity of electricity. The digital future, ethereal and brilliant, is chained to the most physical of resources. And recognizing this changes how we should prioritize what comes now. There's a power consequence in this story worth bringing to light. If artificial intelligence depends on energy at scale, then control of energy becomes one of the most concrete ways to control artificial intelligence itself. And this has two sides, one worrying and one hopeful. The worrying one. The most powerful AI tends to concentrate where there's more energy and more capital to build data centers, which can reinforce the concentration of power in few companies and few countries, those that can afford the colossal infrastructure. The most advanced intelligence could become the privilege of whoever has the biggest plants, deepening inequalities we saw in other episodes. The hopeful side, energy, unlike a secret algorithm, is something many places can produce. A country with sun, wind, rivers, or nuclear capacity has, in theory, a card in its hand in the artificial intelligence era, even if it didn't invent the technology. The geography of energy can redistribute some of the power the geography of chips concentrates. Whoever understands this dynamic sees the technological race in a way the headlines don't show. Beneath the dispute over algorithms and talent, there's an older and more brutal dispute over electricity. And that dispute will shape not just technology, but the balance of power between nations in the coming decades. But before closing, I need to give you the honest counterpoint. Now let me argue honestly against my own alarm, because it's easy to overstate scary predictions about energy. First, humanity has a remarkable track record of solving energy bottlenecks that seemed fatal. It's been predicted, several times, that we'd run out of energy or resources, and innovation always found a way. The prophets of energy scarcity were wrong many times in the past. Second, efficiency gains can be bigger and faster than fear suggests. Leaner artificial intelligence models already show you can do much more with much less, and that frontier is just beginning. It's possible AI's energy hunger turns out to be a passing scare, tamed by efficiency before it becomes a crisis. Third, the consumption projections themselves are uncertain, and some of the most alarmist forecasts assume demand grows forever at today's speed, which rarely happens. I take all of this seriously, but notice the asymmetry that matters. Even in the optimistic version, where efficiency and clean energy keep up, the central point remains. Energy stopped being a detail and became a strategic variable of the technological future. You don't need to believe in a catastrophic energy crisis to recognize that whoever controls energy will have a powerful hand in the artificial intelligence game. That fact is already true today. There's a personal dimension to this story worth bringing close because it changes how you see the technology you use every day. Imagine, every time you ask something of an artificial intelligence, there's a real physical cost on the other side. Energy burned, heat generated, water evaporated in a data center somewhere in the world. We were taught to think of the digital as free and without consequence, but it isn't. This isn't a reason to feel guilty for using technology. It's an invitation to see it with more awareness, to understand that the magical convenience of the cloud has a body and a price. When you understand that artificial intelligence is, at heart, a way of turning electricity into thought, you start looking at the technological race with different eyes. It stops being just a matter of clever software and becomes a matter of energy, of resources, of the planet. And that makes you a more lucid citizen in the conversations coming up about how much energy we'll dedicate to artificial intelligence, where it will come from, and who decides these things. Because those decisions, which seem technical and distant, will shape the world you live in, the climate, the price of energy, the balance of power. The cloud isn't ethereal. It has weight, it has thirst, and it has hunger. And realizing that is the first step to taking part, with awareness, in the future we're building. Which brings us to what to do with all this. So in practice, what to do with all this? And I repeat that it's reasoning, not investment advice for your case. But a few stances make sense starting today. First, see energy as the strategic subject it became again. When you hear about the future of artificial intelligence, ask where the energy comes from, because that's the question that separates hype from reality. Whoever understands this reads the future more clearly than whoever only looks at the algorithms. Second, follow and demand the debate about how this energy will be produced. The choice between feeding AI with polluting sources or with clean energy is one of the most important decisions of our time, and it's, in part, political. It depends on pressure from society. Your voice as a citizen and a consumer counts. Third, use technology aware of its physical weight, without paralyzing guilt, but without the illusion that it's free. And fourth, thinking further ahead, the skills and the places tied to energy, which many considered a thing of the past, may again become central in a world hungry for electricity. The future isn't only digital, it's deeply physical. Artificial intelligence reminded us of a truth the software age had made us forget. In the end, everything runs on energy. And whoever understands this first sees the whole board, and not just half of it. Before we land, it's worth contemplating the beautiful and strange paradox at the heart of all this. We built the most advanced technology in history, machines that converse, reason, and create, and we discovered that its limit isn't intelligence, it's energy, the same raw resource that has moved the world since the first human discovered fire. There's something deeply humble in that realization. However ethereal and sophisticated the digital future seems, it remains bound by the same physical laws that govern a campfire, a waterfall, the sun. Artificial intelligence, with all its aura of magic, is at heart an elaborate way of burning energy to organize information, and that, far from diminishing the technology, puts it back in its proper place, as part of the physical world, subject to its limits and its responsibilities. The Nexialist lens loves these connections, because they dissolve the illusion that the digital and the physical are separate worlds. They aren't. They're the same world. The most advanced future we can imagine depends on the oldest thing there is, the ability to generate and use energy wisely. Maybe the greatest lesson of the artificial intelligence era isn't about the machines, but about us, a reminder that we remain, however much we advance, physical creatures, on a physical planet, with physical resources, and that's where all of this flows. So let me reveal what all of this really means, with no hype and no alarm. It's a projection, not a prophecy. We spent the last few years dazzled by what artificial intelligence can think, and we barely looked at what it can consume. This episode is the reminder that the entire digital revolution, which seems to float on a weightless cloud, actually rests on a brutally physical base. Power plants, chips, wires, water, and electricity. And that base has limits. The great question of the future of artificial intelligence may not be how smart the machines will get, but whether we'll have enough energy, and clean enough, to feed them without destroying the planet or concentrating all the power in few hands. This turns energy, from a boring engineer's subject, into the variable that may decide the pace, the shape, and the fairness of the entire future this cycle described. The other forces, the agents, the robots, longevity, all run on energy. Without it, they're stalled promises. With it, abundant and clean, they can flourish. The future won't be decided only in software labs. It'll be decided also in power plants, in electrical grids, and in the choices about how to generate the energy that thinks for us. The cloud has weight, and recognizing that weight is the first step to carrying it wisely, and nobody will make that reading for you. That's why this channel exists. Let's land, because a theme this big can become abstraction, and I'll stress it one last time. Nothing here is investment advice. It's a map for you to think with. If this reading makes sense, 3 stances are worth it starting today. First, whenever you think about the future of artificial intelligence, remember the energy. It's the question most people forget, and precisely for that reason, the one that reveals the most. Where the watts come from is as important as how smart the model is. Second, treat the way we'll produce that energy as the crucial collective question it is. Feeding the future with clean or dirty energy is a choice that affects the climate, the price of everything, and the balance of power. And it's decided in part with the participation of lucid citizens like you. Third, dissolve, in your own head, the false border between the digital and the physical. The most advanced future is also the most material, and whoever sees both sides at once understands the world better. Artificial intelligence gave us machines that think, but it reminded us that thinking, in the end, is transforming energy. The cloud has weight, has thirst, and has hunger. Carrying it wisely, generating the right energy, the right way, may be the most decisive and least talked about task of our time. You just saw the weight. Now it's on you. Here on Nexialist Future, we don't recap the news. We project what it means for your life. If this map served you, subscribe and hit the bell. This is the 4th episode of a cycle on the forces redrawing the world. We saw artificial intelligence think, the Robot Act, science target aging, and now the energy that sustains it all. Next comes the episode that ties the 4 forces into one, the Great Acceleration. Why everything is changing at the same time. And tell me in the comments, did you imagine artificial intelligence had such a huge energy hunger? Until next Thursday.